Okay, so this is the video for my program for the extra credit. This is my coding. Basically, what this program has to do is it has to count for the number of ones and zeros that are into a register. And to make things easier, I chose to put 4 words for numbers into and label them with the label. And the very first instruction that the program does is it will make R0, the register R0, to point at where these 4 numbers are. So I put it so this is my C number. I put it so that it will point at R0. The first instruction should point R0 to this address, which is the first address of the values. So as we can see, the first R0 is now pointing there. Now I've set a bunch of registers to have a certain value, and I will explain why. So R1 to 0, R6 to 0, R7 to 0, R5 to 0, R3 to 0, R9 to 8, R10 to 128, and R11 to 0. Now it's where the program really begins, we could say. So this instruction will load the first byte in R0, the first byte in R0 into R4, and okay. And so if we go to R0, to where R0 is pointing, we can see that there's this, which is how you write 7 in binary, and therefore R4 is now storing 7. The second instruction will divide 7 by 2, okay, and we'll store the result into R2. Oh yeah, sorry, I forgot this instruction. This first instruction will copy R4 into R2, so that we deal only with R2. And now this will divide R2 by 7 by 2, because R2 is storing 7. Okay, 3. Now add C will check for a carry bit. So since there is a carry when you divide 7 by 2, it will give you 3 with carry bit 1. So the carry bit is updated. The carry bit counter is updated, and therefore in R1 it will add R1 with whatever was stored in R1 before, and plus R3, which is just 0. So R1 should now be going to 1, yes. Then it will compare R2 for 0. Therefore this is basically just saying okay, did we finish counting into this address, into this byte? In this case we don't, because R2 is still 3. So the branch equals will not work. It will skip and it will go to branch rep. So it will go back here, and therefore it will keep dividing. Basically, logical shift right 1 means it will divide by 2. It will shift the ones by one time to the right, so it will divide by 2 only 1 time. So we're dividing R2. Oh wait, yeah. First we're going back. Did I press? Okay. So we divide by, so R2 you can see is now divided by 2 again. So 3 becomes 1, there's still 1 carry bit, so R1 will be now 2. And now keep going, we divide R2 again by 2, so it will be 0, carry bit 1, so R1 will be now 3. Now it will compare to R2. Now R2 is equal to 0, so it will go to the next label, to the next branch instruction. So now we are adding R6 with whatever was in R6 before, plus R1, and R1 again is where we are storing the number of ones that we counted. So R6 will be our final counter for the ones. So R6 is now 3. Now we will subtract R9, which is storing 8, which is the number of bits that are in a byte, in an address, which is what we are counting with this right now. So it will be 8 minus whatever is in R1, which is in this case 3. So 8 minus 3 is 5, and it will store 5 into R7. So yeah, it stored 5 into R7. Now we add now we just basically the R7 is just temporarily counting for the number of zeros that are in the byte. So now we want to store it into R5, which will be our final counter for the zeros. So R5 right now will just be this instruction here will add R5 with whatever was in R5 before, which was 0, plus R7, which is what we just counted. So R5 will be 5. Yes. Now we will reset the temporary counters for the 0 and the 1 and the ones. So R1 and R7 will become 0 again. Now this instruction, this add R11, R5, R6, basically is just to count if we finished counting the numbers. Basically, we want to add the number of ones and the number of zeros that we counted so far and add them into R11. Okay, and we will compare R11 to R10. Now remember, R10 was storing 128, which is the number of bits in total that are present into 4 words, since each word is storing 32 bits. The way I made this is basically so that this is just to check that we didn't finish counting for the 4 words, for the 4 numbers. So yeah, R11 will now be 8, which is how many bits we counted so far. It's correct. R11 is not equal to R10, therefore the branch equals will not work. It will skip. It will go to add R01, which what this does is just basically update for R0, which was storing our first address here. It will update it to point at the very next instruction. So this would be 121307141. Now if we point at where this is, we can see that is right after the the address we were counting before. And now this will go through again, only this time since a word does take 32-bit space, whatever the number. So even if it was a 7, now all these zeros will be counted, and therefore here, instead of counting for the ones with this, it will just it will try to divide, and we see there's no carry bit since it's a 0, and it will immediately go to this, so it will immediately go here, and after it goes here, I'll keep on going, I'll explain. After it goes there, well, R6 will not be updated because R1 was never updated since there are no ones into that. Therefore R7 will be 8 because R9 is 8 and R9 minus R1, which was 0, 8 minus 0 is 8. So R5 will now be whatever was in R5 before, which was 5, plus R7, which is now 8. Together, it's 13, which is hexadecimal for D. So we can see R6 was never updated and R5 was. So now we can just go through the whole thing, stop it. And now we can see that R11 is storing 80, which is hexadecimal for 128. Which is correct because R11 was counting if we were counting for 128 bits, and we can see checks, it's also the same as R10. Now we can see R6, the number of ones, there were 8 ones into these 4 numbers, and 78 is whatever was 128 minus it's 100, so 100, yeah, 120 zeros. So in this in this register, in this R0, in these label values, there are 120 zeros and 8 ones, and we can count here if I can find them out. Okay, so 1, 2, 3, and this is all zeros. 4, 5, 6, 7, 8, and it is correct since, well, this is the 2, this is what 2 is, this is what 17 is, 16 plus 1, 17, and then this is the 6, 4 plus 2, so it works.